Hello everyone. Today I'm truly excited to present my proposal on data provenance for generative artificial intelligence. In essence, my goal is to identify and trace data used in generative AI. Today's leading generative models like GPT, Gemini, and Llama are trained on vast and diverse datasets. These datasets include news articles, books, music, code, images, and much more. The scale and diversity are what make generative models so powerful and enable them to generate everything from complex text to photorealistic images. But these impressive capabilities also create profound risks. First, my research showed that generative models memorize thousands of training samples and then regenerate them verbatim, word by word for text like the Harry Potter book, and pixel by pixel for images like the face of this woman. As a result, there are now over 100 ongoing lawsuits with claims of over 100 billion euros. Second, generative AI is exploited to produce misinformation and fake news at scale. This undermines our democratic processes and makes it harder to trust the information we see online. Finally, generative AI creates data loops. Content produced by these models is published online, then scraped and reused to train the next models. In the long run, these data loops degrade the quality of models. Specifically, they amplify harmful biases from earlier models and carry them over to new models. All of these risks point to the same scientific challenge: data provenance tracing for generative AI. We must know where data comes from and how it is used. What's more, the EU AI Act demands that we provide this data provenance for Gen AI now. Article 15 requires robust marking of generated content and takes effect on December 2nd this year. Article 53 requires compliance with copyright laws and already took effect last year. The problem is highly urgent. I spoke to my collaborators at Google and OpenAI. We all want to break the data loops, but we cannot do that with the current methods. This project aims to deliver exactly this missing scientific foundation. My solution is to build a unified data provenance framework for generative AI. This requires addressing three fundamental scientific questions. First, on the input side, the question is how to reliably identify data used to train generative models. The second question during model training is how we can control memorization so that generative models learn diverse general patterns instead of memorizing individual samples. And the third question on the output side is how to persistently mark and identify generated data. Let me start with the first part, reliable data identification. Previous data provenance methods aimed to identify if a single data point, like a sentence or an image, was used to train a generative model. In 2024, I made a breakthrough. It was twofold. First, I showed that, given the massive scale of these models, signals from single samples are too weak to identify them as training data. Second, as a solution, I showed that when we extract and aggregate a large number of signals per sample and across a dataset like a whole book, then we can provide a strong enough cumulative signal to reliably identify training datasets. But current methods operate at two extremes. They either test individual samples or entire datasets. As I showed, signals from single samples are too weak. For datasets, we do not know in advance how much data is sufficient to obtain a required significance level. In some cases, the signals from a dataset are enough. In others, they are not. For example, when more evidence can be requested for a high-stake legislation. Instead, in this project, I propose an adaptive evidence accumulation framework. It works as follows. We start with a small batch of data, for example, a few sentences. We extract informative signals from these data points and compute initial evidence. If the null hypothesis holds, meaning the data was not used during training, then the evidence should remain small. But if the data was used during training, then we can collect more data and stronger signals to accumulate more evidence until we reach the required significance level. The final outcome will be a practical statistical framework that offers valid guarantees at any point in the process. What's more, generative models are not only trained on large amounts of data, they also generate large amounts of data. My innovation is to unify the identification of both training and generated data into my new statistical framework. I will design novel methods to extract strong signals from sources like loss trajectories, token probabilities, or internal model activations. These signals will form signatures of the data and will provide us with strong provenance evidence for my new statistical framework. Now, to identify the strongest provenance signals for training data, we'll analyze memorization in generative AI. Currently, we face a deep scientific gap. Prior work measures memorization by comparing training and generated samples. But this captures memorization only when a training sample is copied to model's outputs. I propose to close this gap by measuring memorization of each sample as a continuous score. I have already introduced such a score for contrastive learning. Now the challenge is how to transfer the definition to generative models and compute the score efficiently without retraining models from scratch. Once memorization is measurable, it becomes controllable. I will use my continuous score to identify the samples with the highest level of memorization. Then, the continuous score will also serve as an objective to provide targeted mitigations. The score should be sample-specific, so mitigations remain selective. All other samples are unaffected and continue contributing fully to learning diverse and general patterns. This approach will mitigate harmful individual sample memorization while preserving model utility. The understanding of memorization will guide us in designing data marks that are retained by generative models. These marks will also support the identification of generated data. Current watermarking methods are not enough for provenance tracing in generative AI. The standard watermarks are usually unique per individual sample. As a result, when the next model, in this case model 2, is trained on the watermark data, these watermarks are simply ignored. These watermarks do not propagate the outputs from model 2, so we need a new approach. I propose radioactive learnable marks. These marks should be detectable when a new model is trained on the watermark data. My preliminary work shows that this is possible for models that generate images bit by bit. My project will generalize this insight to all types of generative models. In particular, my radioactive marks will form learnable patterns that can propagate to the next models. The signals from radioactive marks will be detected and integrated into my statistical framework. They will amplify the signals for data identification, and the outcome will be a method which will provide statistical guarantees on whether data is generated and if the generated mark data was used to train new models. This last part will complete my vision of creating a unified data provenance framework. My approach, which is firmly rooted in my recent research, will reliably identify data that is ingested for training, memorized data, and data produced by generative models. And this brings me to the real-world impact. Right now, the EU leads the way in AI regulation. But without the right methods, regulations are all bark and no bite. My project will provide the scientific foundations for enforceable provenance tracing of training and generated data. It will provide individuals, artists, publishers, or in general, data owners, with tools to detect whether the data was used to train generative models. By breaking the data loops, we'll ensure that the new models are not trained on the generated data so that they are safer and do not carry over the biases from previous models. Finally, my project will enable prevention of AI-produced misinformation by providing methods for data provenance verification. In short, my data provenance framework for generative AI aims to make what is currently impossible possible, provide data provenance tracing in the era of generative artificial intelligence. Thank you.